Hello everyone. Today we'll delve into a fascinating subject in the realm of continuum mechanics, constitutive laws. These laws encapsulate the complex relationship between stress and strain in physical materials. Let's get started. First of all, a constitutive law, in essence, provides a mathematical relationship that defines how materials behave under various conditions. It sets up a link between stress, the internal forces acting within the material, and strain, the consequential deformation. This rule enables us to predict material responses to different forces or stresses, thereby playing a pivotal role in fields like engineering and physics, where understanding and predicting material behavior is crucial. In a mathematical expression, a basic linear elastic constitutive law can be presented as sigma equals E epsilon, where sigma stands for stress, E for the material's modulus of elasticity, and epsilon for strain. This example is quite simple, so here is a compilation of different equations. Now let's turn to a daily life example, butter. At room temperature, butter behaves as a Bingham plastic, a type of viscoplastic material. This means it behaves as a solid up to a certain stress, known as a yield stress, and flows like a liquid beyond that. The constitutive law for butter, following the Bingham plastic model, is expressed as follows, where sigma is stress, sigma y is the yield stress, eta is the plastic viscosity, and du on dy is the rate of strain. To be more precise, at colder temperatures, butter is stiff and retains its shape, acting like a Hookean elastic solid. It responds linearly to applied stress, and the deformation disappears when the stress is removed. When the temperature rises slightly, butter doesn't immediately flow like a Newton solid. Instead, it behaves like a Bingham plastic. This means it needs a certain amount of stress, the yield stress, before it starts to flow. Further warming transitions butter into a Newtonian fluid phase. When fully melted, butter will flow freely and conform to the shape of its container. The rate of deformation is proportional to the applied stress, and the deformation doesn't reverse when the stress is removed. Let's demonstrate this. This butter, straight from the fridge, is relatively solid as the stresses within it are below the yield stress. When I apply a force with this knife, exceeding the yield stress, the butter starts to deform and spread, behaving more like a fluid. This is the Bingham plastic behavior. But what happens when we add heat to the equation? As you can see, with the addition of heat, the yield stress decreases rapidly and the butter begins to melt, behaving entirely as a fluid. In conclusion, constitutive laws provide us with a way to understand and predict how materials behave under different conditions, from skyscrapers to a simple pat of butter. Thank you for watching this video.